Hello, everyone. Welcome to the Symposium on the roles of different domain general and domain-specific skills in children's mathematical competence. I'm Sam Cheung from Hong Kong, the organizer of the Symposium. To solve mathematical problems, there are many things that individuals need to do, such as comprehending the problem statement, retrieving relevant information from the memory. Therefore, all this drives us to think about one issue, that is, solving mathematical problems does not only involve mathematical skills, but also a wide range of domain general skills. Therefore, in today's presentation, we'll have 3 studies that investigate the contributions of various domain general and domain specific skills to different types of mathematical problem solving. So after this free presentation, we are also very glad to have Professor Kerry to share with us his thoughts on these 3 studies. So may we now pass the time to our first presenter, Dr. Amy Yang from Beijing Normal University. Thank you.
You are still on mute, I think.
Sorry, can you hear me now?
Yeah, that's fine.
Yeah, I think I was controlled by somebody. Thank you. Can you see my PowerPoint?
Yes, that's fine.
Oh, okay, let's begin. Firstly, let me introduce myself. I'm Xiujie Yang, and you can also call me Amy. I'm from the Faculty of Psychology in Beijing Normal University, so my location is Beijing. And I hope you all stay well during this difficult time. So today, my topic is about how do phonology processing skills contribute to Chinese reading and arithmetic fluency. So we want to know about the potential mediating role of processing speed. As we all know, acquiring the proficient reading and arithmetic fluency at young ages are very critical for future academic success, and many longitudinal study has proven it. It has been well documented that reading and mathematics are highly associated. For example, in our study in 2016, we found that Chinese primary children with developmental dyslexia often confound with arithmetic difficulties. Actually, in 1987, when
I think she's having some issues with her internet. Let's see if she can come back.
Do we want to maybe skip over Amy and then come back to her if when she's able to get back on?
Okay, no problem. So so maybe we go to the second presentation first, maybe. So Winnie, please, thank you.
Okay, thanks. Let me share my screen first. Okay, So hi everyone, I'm Winnie Chan from the University of Hong Kong. It's nice to meet you all here. Today I'm going to share with you my study on kindergarteners multi-digit number understanding. So multi-digit numbers are complex to young children actually. They are built on the base 10 numeration system. In multi-digit numbers, each digit actually represents a specific magnitude, and that magnitude depends on its position in the number. Say, for example, in the number 48, 4 here means 40 because it is in the tens place, and 8 means 8 because it is in the units place. So this is something to do with place value concept. Place value concept or place value understanding is important to math learning. In our previous study, we have found that first graders' place value concept is the single strongest predictor of first graders' math difficulties. So usually children learn place value concept or multi-digit numbers in their elementary school level. So do you think young children, kindergarteners, can understand multi-digit numbers? The answer is yes. Actually, they have some partial understanding of multi-digit numbers. Probably they have learned it from their daily life exposure to these numbers. In some previous studies, it has shown that when they are asked to compare two quantities, 5-year-old kids can do it better if the quantities are represented by numbers instead of some concrete objects. Even 3 or 5-year-olds can also perform the task at above chance level. So when you ask the kindergarteners to write out the numbers, of course they will make errors, but those errors are actually intelligent errors because those errors are quite similar to overgeneralizations in English spelling. For example, in the number 231, they will write out all the zeros behind 2, or they will write 210031. So actually, you can see they are trying to make sense of the number. They are making some systematic and meaningful errors. So in my study, I want to solve two problems. The first one is about the measurement. So in previous studies, there are different tasks using different tasks that the researchers will use to tap into multi-digit numbers. But we want to know whether they're actually measuring the same thing or not. And the second question is whether early understanding in multi-digit numbers really is important, whether it can predict later math achievement and place value concept. So we conducted a longitudinal study. There are two phases. In phase 1, we invited 146 kindergarteners in Hong Kong. They were 5.6 years old. In this phase, we asked the children to complete several multi-digit number tasks and also some control measures, including nonverbal reasoning task and a visual spatial working memory task. And in the second phase, we invited them, some of them, 66 of them, to participate in our study again when they were in grade 1. And this time we asked them to complete a math achievement test, key math, and also a place value task, the strategic counting task. So the purpose of phase 2 is to see whether their performance in phase 1 in multi-digit understanding can predict their math achievement in phase 2, right? Phase 2. So in phase 1, we asked the children to complete several multi-digit tasks. So these tasks are taken from previous studies. According to the triple code theory of number representation, actually numbers can be represented in different forms, verbal, visual, or quantity. So we try to fit different common tasks into one of these codes. So we have 7 tasks altogether. For verbal code, we have read aloud numbers. That is, we ask the children to read out a number. We give them a number and read it out. The second task is verbal counting, that is to recite the counting sequence. The third one is next number task. So actually we show them a number, but then we ask them to verbally tell us the next number. For the visual code, we have two tasks. One is writing numbers. We read out the number and then they have to write out. The fifth task is number pattern task. We show them a sequence of number, and they have to work out the pattern behind and fill in the missing number. For the quantity code, we have two tasks. One is the number comparison task. They have to tell us which number represents more. And the other one is make a number task. So they are given 3 digits, for example, and they have to make the smallest 3 digits number. So they have to make sense of the magnitude behind represented by the number. So we want to know whether these different tasks are actually measuring the same construct or they are measuring different constructs or different aspects in multi-digit numbers. So we conducted a factor analysis, and the result shows that actually they fall into one single factor, and the factor accounted for 60% variance. So this is what we can find. Now we use the factor score derived from phase 1 to predict children's performance in phase 2. As you can see in the diagram, the multi-digit understanding in phase 1 can predict both the place value understanding and math achievement in phase 2. And there is a mediation relationship. That is, the place value understanding is the mediator in this case. Children who have better multi-digit understanding in kindergarten will have better place value understanding in their grade 1, and this probably support them to have better math achievements in grade 1 as well. Based on these findings, we addressed these two questions. The first question about the measurement, we found that perhaps at least in kindergartner age, different commonly used multi-digit tasks are actually measuring the same construct. And together they can provide perhaps a better assessment of multi-digit number understanding. And we use that measurement to predict children's later math achievement. And we found that this early partial understanding of multi-digit understanding actually is quite important. It is predictive of the later math achievement, and this relationship is mediated by the place value understanding. Based on these findings, there are some important implications for future studies. First of all, young children, well before they receive formal instruction in multi-digit numbers, can make some sense of multi-digit numbers. So this is consistent with previous studies. What's more, we found that actually it is important to their later math achievement, and this relationship is mediated by the place value concept. In the future study, it is important to see why children can acquire the early understanding of multi-digit numbers. One possibility is through their informal exposure to these numbers in their daily lives. So it would be interesting to see how we can support children to have some rich exposure to multi-digit numbers that can help them to acquire a better understanding of multi-digit numbers before they go to elementary school. And also about the measurement, the current multi-digit understanding assessment is not perfect, of course, because it is very long. It consists of 7 tasks. So in our future study, we're going to streamline the test, so it will be more simple, it will be more convenient, quick for children to complete for future study. So that's all for my sharing. Thank you very much.
So thank you, Winnie. So it goes to the Q&A section, I mean, for Winnie. So do you have any questions for Winnie at the moment? If no, never mind. So we might go back to Winnie later after all the presentations. So may we now pass the time back to Amy, please. Thank you, Amy.
Can I share my PowerPoint now?
Yep, I
Yes.
just enabled that. Sorry about that.
Okay, and now it's sorry for my loss. Sometimes the web is not very stable. Yeah, and I will continue my introduction. So about phonological processing skills, we have introduced that the Wagner defined 3 different kinds of skills, including the phonological awareness, phonological memory, and also phonological recording lexical access. And sometimes we assess them with different assessment. For example, for the run, we sometimes use digit, sometimes we can use like the objects or color. So what we want to consider is whether phonological processing skills can contribute to the co-development of reading and mathematics. We luckily have recruited different participants from Cebu Island in Philippines. So the children there are preschoolers. And also we recruited children from mainland China in kindergarten 3. We also proven the same results that phonological processing is very important, both reading and mathematics. And we also got the same result from Hong Kong. These Hong Kong children are from primary 1 to primary 2. However, little research has proven direct evidence about whether the phonological processing contribute to reading fluency and arithmetic fluency for the same reasons. Also, we know that they are very important. And the second question is that how do different phonological processing skills, including the phonological awareness, run, and also the phonological memory, can play different roles in academic development? Here, we propose the general processing speed mediating hypothesis. We were thinking like the processing speed has been widely considered as an important cognitive foundation for both the fluency of reading and also fluency of mathematics. Moreover, some studies have shown that processing speed is involved in run, as we all know that individuals with slower naming speed had a higher possibility of slower processing speed. So we were thinking that processing speed might mediate the relations of run with reading fluency and also the relation of run with arithmetic. And in contrast, phonological awareness and phonological memory might directly contribute to both the reading fluency and mathematics fluency. Here, we recruited children from one elementary school in Beijing with a sample of 145 fifth graders. So because as we have already shown that preschoolers and kindergarteners and even the primary school children from lower grades has been shown that phonological processing skill is very important to their reading and mathematics. So here we recruited children from higher grades. And you can see that the mean age of children at the start of the testing is 12 years old. And these participants are from middle to upper middle class families, and their native language was Chinese. We actually here use different tasks to measure children. The first task is Chinese reading fluency. So in this task, we use the standardized Chinese character recognition test. Children need to compose their Chinese characters into one word. So for the arithmetic fluency, we use the standardized whole computation fluency task. So children need to finish all the measures within 7 minutes. And the last one is processing speed. Here, we actually use a digit cancellation test. In this test, we presented different digits from 0 to 9, and they are ordered in randomly. So children need to digit to cancel the digit 3 in all the randomly selected digits in one sheet. So the limited time is 3 minutes. And for phonological awareness, we use the phoneme deletion task. Because these children are Chinese children, we use the Chinese characters in the phonological awareness task. For example, 天 in English it is called the sky. We ask the children to tell us what's left when the t was deleted from the word 天. So the answer is 天 en without the t. And the rapid automatized naming, we use digit run, in which children need to speak out of all the digits in one sheet as soon as possible. And the third phonology processing task was phonological memory. It is a forward digit span, and we actually use the subtest from the intelligence skill in the fourth version in Witcher's law, and it was used to assess the phonological memory. And from this correlation table, you can see that firstly, for phonological memory, and it was associated with Chinese reading fluency rather than arithmetic fluency. But for RAN, the rapid naming and also phonological awareness, they were both associated with Chinese reading fluency and arithmetic fluency. And for our first question, we want to know whether the three phonological processing skills contribute to reading fluency and arithmetic fluency for the same reasons. And you can see that actually, firstly, phonological memory was not associated with Chinese reading and fluency and arithmetic fluency after we controlled the vocabulary knowledge, nonverbal IQ, gender, and age. In contrast, both the RAN and phonological awareness are very important for Chinese reading fluency and arithmetic fluency. Therefore, we can conclude it here that in phonological processing, the most important component are the phonological awareness and RAN. And for the second question, we want to know how do different phonological processing skills play roles in academic development, especially academic fluency. As we have hypothesized that processing speed might be very important between the relations of RAN and Chinese reading, we can conclude it from this mediation model that it was demonstrated as our hypothesized. And secondly, actually for phonological awareness, it can contribute to Chinese reading fluency and arithmetic fluency directly. And here you can see we have controlled the 4 covariants, including vocabulary knowledge, nonverbal intelligence, gender, and age. Actually, I want to discuss from 3 aspects. And the first one is that we can see the phonological awareness and RAN were moderately correlated, and they were independently contribute to Chinese reading fluency and also the arithmetic fluency among children. And this is actually consistent with Wolf's double deficit hypothesis, and to show that children can be characterized with dyslexia with phonological awareness and RAN. And also, furthermore, we can see that phonological awareness and RAN was also consistently important for arithmetic. This gives us an indication that maybe Wolf's double deficit hypothesis can be used to detect children at risk of dyscalculia. So do they contribute to reading and arithmetic for the same reason? From our second model, we can say not exactly. This is for on the one hand, although Chinese does not directly require the phoneme processing since each character represents a syllable, mainland Chinese children can use pinyin as a scaffold to recognize characters and words. Therefore, phonology awareness is very important for Chinese reading. On the other hand, the phonology awareness helps the individual to hold the phonology representations in memory while we selecting, implementing, and monitoring the strategies for mathematics problem solution. Therefore, we also see that phonology awareness is very important for mathematics fluency. So consistent with the hypothesis, the processing speed played a partial potential role in the relation of run and Chinese reading. This suggests that the relation of run with reading should be more complicated than we previously stated. So when predicted Chinese reading, run not exactly reflect the global role as a speed of processing, but also indicated that the automatic access of the familiar stimuli also stayed in our long-term memory. On the other hand, we found that phonological memory failed to predict either the Chinese reading or arithmetic fluency after we control the nonverbal IQ, vocabulary knowledge, and age and gender. So we were thinking that maybe phonological memory is more important when children are in the stages of at the early stages. As we have shown before, phonological memory is really very important when children are in kindergarten. And on the other hand, we found that phonological memory was highly associated with run and phonological awareness. This may be indicated that it has much overlap with the other two phonological subskills. So we can conclude that firstly, phonological skills play different roles in academic performance, and phonological awareness and run are more important than phonological memory when they were in relation with both reading and arithmetic. And secondly, phonology awareness and run contribute to reading and mathematics for different reasons. This is because the processing speed can mediate the relationship of run with reading rather than arithmetic. And on the other hand, phonological awareness can directly contribute to reading and mathematical fluency. Actually, in our study, there are some limitations. Firstly, in this study, we only recruited children from the 5th grade, and they were in Beijing. We were thinking that maybe children from other cities maybe show different results, and we want to do it in our future studies. And secondly, this is actually concurrent study design, so we didn't even control the prior academic fluency. And moreover, we were thinking that intervention studies might be needed for children at risk of the dyscalculia or dyslexia. Thank you. That's all for the studies, and thanks to the school and children that participate in this project. Thank you.
Thank you, Amy. So do you have any questions for Amy at the moment?
I just dropped a question in the chat that if we have time, I would love to get to, and that's about the directional hypothesis that was suggested. So I know the idea was that processing speed mediates the relation between RAN and Chinese reading skills. Why do we think that that's not the other direction? Do we think that it might be that processing speed is underlying some of those basic skills like RAN? And so in turn, we see that RAN might be mediating the relations between processing speed and outcomes.
Okay, thank you for your question. Actually, this has been proven in let me show you the model here. We have ever tried the other way around, that for processing speed was used as an independent precursor, but it failed. So we were thinking there might be two reasons. And the first reason is that maybe processing speed is shown as a domain general precursor. And maybe in this model, we actually has proven in kindergarteners that the processing speed can be shown as an independent precursor. But when children went to a higher grade, maybe the processing speed is more like a general precursor, more like a general precursor that they can predict both the reading and mathematics, and processing speed is shown as a higher, like can support the relations between processing speed and academic performance. Yes.
Thank you.
That may be the reason. Thank you.
Great, thanks.
Okay, thank you. So are there any other questions? If no, let's move on to the next presentation. So this time I would be the presenter. So I would like to share the screen with you now. So today my presentation is about the cognitive precursors of young children's addiction story problem solving. I'm Sam, I'm from Hong Kong. So this study is also, I conduct this study together with two other researchers, one from University of Oxford and the other one is from the Chinese University of Hong Kong. So during kindergarten years, we noticed that children start to learn about addiction. However, we found that addiction problems can appear in different forms. For example, one simple type of addition problem is we just ask them, so what is the sum of 1 and 2? Can you tell me the answer? So sometimes the addition problems can be embedded in a story. For example, and this kind of stories might vary in their content. It might be combination story problems, such as this one. So we would notice that. So let's say Fred has 1 biscuit, George has 3. So how many biscuits do they have altogether? So sometimes it might involve it might involve some changes. For example, just like this one, Peter has 4 biscuits. Dad gives him 1 more. So how many biscuits does Peter have now? And the last one is it seems to be more complicated. It requires children to compare 2 sets of quantities. For example, let's say this one, John has 3 biscuits, James has 1 more biscuits. Then how many biscuits does James have? So we find out, okay, so addition problems can appear in different forms. So all these problems, do all these problems require the same sets of skills? Are they equally difficult? So because in past studies there are some tendency that children perform better in combination story problems than the other 2 types. So what are the reasons behind? So we would like to explore a bit about it. And then when we look at previous studies, when we look at relevant literature, we found that so actually there are 2 sets of skills that are very related to children's numeracy competence. One set is about children's general cognitive skills, such as vocabulary knowledge, phonological awareness, or RAN. All these things, all these variables are positively correlated to children's early numeracy skills, such as addition, and then some other basic numeracy skills. On the other hand, we find out because addition requires a number of other number knowledge. So we are thinking that whether basic numeracy skills actually also predict advanced numeracy skills. And there is some empirical evidence about that in the past literature. For example, we noticed that counting numerical magnitude comparison, including symbolic one and non-symbolic ones, all these might predict children's mathematical achievement in the future. So based on these 2 lines of studies, we want to ask 2 questions. So the first research question that we would like to ask is, do young children vary in their performance on different types of addition story problems? Is it easier for them to to just give them a number facts problem and then they need not analyze anything and then they just answer it? Or it is or is it more concrete for children to understand the story by presenting them a story and then it is easier for them to answer it? So we are interested in exploring the difficulty level of these various types of problems. So the second question that we would like to ask is, what general cognitive and early numeracy skills predict young children's ability to solve different types of addition story problems? In particular, let's say when we are solving story problems, does it call for higher level of vocabulary knowledge or language skills? So these are the research questions that we have in our mind. So so in order to achieve our research question, so we collect data in the Philippines, and then the number of participants is 296, and half of them were boys, half of them, the other half were girls, and all of them came from some low to middle income communities in Cebu, the Philippines. And then we have 2 data collection time points. So the 2 time points were about a year apart. At time 1, we noticed that children's age is about 5.78 years. And at time 1, we administer a number of a number of tasks that tap on children's domain general skills as well as some domain-specific skills. For example, we have a vocabulary knowledge task, and then we tell it, we say a word, and then children need to point to the corresponding picture. We have a syllable deletion task as the phonological awareness task. We also have a rapid object naming task, and then these 3 are the domain general skills that we have included. And there are also 4 other domain-specific skills. So one is object counting, asking children to count how many items there are. And then we have row counting tasks to ask children to count from one particular number to another number without presenting them any visual information. And then we have a symbolic numerical miniature comparison task, asking children which of these numbers represents a larger value. And lastly, we have an addition facts knowledge task. And then we also collect a number of things at time 2. And we have combination problems, we have change problems, and we have comparison problems. So here are the means and correlations of various things. So here you can see that the combination problem, it seems to be children perform better on combination problems. And then so here you will see that we conduct some repeated mention analysis and found that and then the post-hoc test showed that children perform better the best on combination problems, followed by change problems and then comparison problems. And next, this table shows the correlations of different domain general skills and domain specific skills with different types of addition story problem solving. So it shows that all of them have quite good correlation. So here you will notice that the RAN had negative correlations with the performance. The reason is because for the RAN we use the time spent on the task. So here you will see that the longer the time they spent on the task, the better their performance on different types of addition story problems. So next we use regression analysis to analyze the relationship between different variables. And then so the first one that I'm showing now is the combination problems. So here you will see that the domain general skills are predictive, are correlated with the outcomes, but once when domain specific skills are entered, only vocabulary remains significant. For the change problems, again, we can see that vocabulary and phonological awareness are correlated with children's performance on change problems in the second step. However, when all in the last step, when all the things are entered, so it is noticed that all of them, all the domain general skills lost their explanatory power. So the last one, for the comparison problems, a similar pattern was observed. So here you can see that the domain general skills are correlated with the performance on comparison problems. However, when at the last step, only object counting and route counting remains significant. So based on because we noticed that the correlations between children's performance on these three types of problems are quite highly correlated with each other. So we have conducted an additional regression analysis by combining all three types of problems. So here are the scores. Here are the results. And again, object counting, row counting, and number comparison skills are regarded as play a significant role in children's performance on addition story problems in general. So our findings show that object counting skill, row counting skill, numerical managerial comparison skills were predictors. They were very important. So we are wondering why counting skills play an important in addition story problem solving. So one reason is that, so let's say they rely on row counting, let's say counting up to get the answer. But we notice that object counting is also very important. These happen perhaps because some children might still rely on the count or strategies by using different objects to help them to get the answer. But for comparison problems, so we find that only object counting and row counting skills were predictors. So interestingly, even though we need to compare two sets of quantity, numerical managerial comparison skills were not a significant predictor. So we think that it deserves more attention. It deserves further investigation about it. And then we noticed that phonological awareness often lost their predictive power, but vocabulary knowledge is important. So, but we wonder why, because only vocabulary knowledge is only related to combination problem. Is it because the sentences are relatively more complex, or is it because of some other reasons? So we need to further investigate about it. But the most interesting thing is that addition facts knowledge was not predictive at all. So why does it happen? So is it because for addition fact knowledge, children might rely more on their just retrieval of number facts? So and then when they need to analyze the story, there are other skills that might be involved in. So here are the implications of our studies. So the first, we think that in order to support young children to solve addition story problems, so it might be useful to provide training on basic numeracy skills as well as vocabulary knowledge sometime, especially for combination problems. And then teachers might also adopt slightly different strategies and might teach the three types of problems step by step because they vary in their difficulty level. So here are the limitations. One limitation is that we haven't counterbalanced the presentation order of different types of addition story problems, and we have not controlled children's ability to solve the story problem at time one. And we recruit participants from Cebu only. So in future, we think that because we presented problems verbally, so it might be interesting to see whether the same set of results can be obtained when the thing is presented in a written format. And we can also include more different kinds of general skills or language skills. And lastly, we might also investigate whether the basic numeracy skills is a mediator of the relationship between the general skills and the story problem solving. So that's all for my presentation, and I would like to thank the UBS Optimist Foundation for supporting this study and the Atkins Early Learning Foundation to collaborate with us in collecting data. Thank you very much. So, so do you have any problems? Thank you. So if no, I will pass the time to our discussant, Professor Kerry Lee. So Professor Lee, please. Thank you very much.
Hi everyone, can you hear me?
You need to be a bit louder, please. Thank you.
Okay, can you hear me now? No?
Not exactly.
Okay, let me just give me a second. Or is it now? Yeah? Okay, wonderful. All right, let me just give me 1 second. Okay, I was going to say thank you everyone for staying up late, but I then realized that most of you is, for most of you, it's actually the morning or in the afternoon. So thank you for staying anyway. And thank you for inviting me to be the discussant for these 3 excellent studies. Now, I always find it useful after 3 talks to just have a bird's eye view of the main study. So with Amy's study, she works with 5th graders in Beijing, focusing on phonological processing and processing speed as a mediator. And she was interested in whether they predicted fraction computational fluency. And she found a mix of direct and indirect paths, which I would summarize a little bit later on. Winnie worked with younger children from Hong Kong this time, and she was looking at multi-digit understanding and whether that predicted math achievement 1 year later at grade 1. Now, as far as I understand that in terms of the main general measures, she used those as control measures, and she found that there was a significant predictive relations between multi-digit understanding and math achievement 1 year later. Sam worked with Filipino children from Cebu, and he used a large range of measures, really. And he found that there were significant predictive relations for most of the predictors, with the one exception that addition fact didn't seem to be all that important. Now, Amy's study was very interesting. Her main question was whether different phonological processing skills contributed to reading and math, and her findings seem to suggest that indeed there are different pathways that works. As you can see from the path diagram, phonological awareness and RAN seems to have a direct effect on arithmetic fluency. And perhaps somewhat surprisingly, given that arithmetic fluency is a measure of speed, processing speed did not have a direct effect on arithmetic fluency. I was reading her slides and also listening to her talk, and she was introducing RAN as perhaps a alternative measure of processing efficiency in terms of speed of accessing the lexicon. So perhaps some of that variance in terms of processing speed is already captured by RAN. Now with Winnie's talk, her study was focused on how we can go about measuring multi-digit understanding. She came up with a very extensive list battery of tasks to measure this, and she administers that to children in upper kindergarten. Now, some of you who are not from East Asia may wonder, gosh, those numbers are pretty large for kindergarten kids. But that's actually not that unusual. I remember talking to a kindergarten teacher one time, and she was asking me, how come my kids are having difficulty solving just 3-digit addition questions? They are in K1 already, and these are only word problems. And I was a little bit dumbfounded. I was thinking, why were you giving them that kind of questions? But the system here is such that depending on which kind of kindergartens you go to, that really is not unusual at all. So her finding showed that multi-digit understanding predicted math achievement, and there was also an indirect effect. But what I missed from that was the extent to which the domain general measures also had, but I wasn't sure whether they had a direct effect or not. Now with Sam's study, I combined his 3 slides into one, so that it was easier to get a summary view. There was a lot of commonality across the 3 types of word problems. So you'll recall that he used combination word problems, change problems, and also comparison problems. And if you look at these 3 sets of summary findings, the main differences came from the extent to which vocabulary predicted performance. So vocabulary only seemed to have a significant role for the combination questions. Similarly with number comparison, there were some differences across the 3 problem types as well. Now, what I thought was notable was that addition fact didn't seem to have a significant effect, and it's kind of ironic that in school, in Hong Kong schools anyway, and perhaps I'm not sure about in the Philippines, addition fact is really quite emphasized in the curriculum. Now, so some observations for the 3 studies. Now, these 3 papers are really quite different, both in terms of focus and also in terms of methodology. And perhaps because of that, I actually found it really quite tough trying to draw something across the 3 studies. Now, it's good to see a move away from the usual suspects in terms of working memory and the other usual domain general measures. But with the different age groups, sample characteristics, study design, it's really difficult to compare across those studies. Now, Amy's study seems to suggest that arithmetic fluency is predicted by both domain general and domain specific predictors. But I thought that her domain specific predictors were actually cross-modal, and they gauge quite foundational phonological capabilities. So, you know, I guess one could argue, were they really domain specific, or was there an element of domain general capabilities that were being measured, especially with RAND? Now, Winnie didn't report on whether the domain general measures were significant by themselves or remain so with the domain specific variables added in. But what she did show was that the domain specific measures were significant, even controlling for the domain general measures. Now, Sam showed that his battery of cross-modal domain general measures did not survive inclusion of the specific variables in the regression models. So that was quite interesting. But if we focus on the domain general measures that are common across the studies, there are some inconsistencies across, especially Amy's and Sam's studies. Now, in both of those studies, RAN and processing abilities were used, and they were significant predictors of the math outcome in Amy's, but not in Sam's studies. Now, what is the source of this inconsistency? Now, I must preface what I'm going to say with the fact that these are very different studies, and in fact, the math outcomes were different as well. But perhaps, you know, it's the difference in findings due to the age of the participant, right? So children in Amy's studies are older, quite a bit older. But then one would have thought that if age is the main explanation, older kids should be more proficient in basic math problems and would be less reliant on domain general skills rather than the other way around. Now, in Sam's study, both RAN and arithmetic fact retrieval were not predictive of success in the story problems. And I think within the study itself, this is consistent, because if RAN is indeed a measure of the rate of access to lexical information, that shares some commonality with arithmetic fact retrieval. But then this leaves that inconsistency with Amy's findings remaining unsolved. Now, when I was reading the three studies, one thing that came to mind was the different ways in which we can model relations between domain general skills, domain specific skills, and math performance. Now, Amy used this approach where domain general skills was set as a mediator. Her study was cross-sectional in nature, and Winnie also used this kind of setup, but with her study, it was a 1-year longitudinal setup. Now, there are some studies, I think last week's presentation focused on looking at bidirectional relation. So it's perhaps the case that domain-specific skills causes some differences in domain general skills and vice versa, either cross-sectionally or longitudinally, and then they have their unique contribution to differences in math performance. Now, older studies or perhaps those, for example, with Sam's study, he used a regression approach and really just contrasted and setting domain general skills and domain specific skills at the same level and contrasting their effects on math performance. Now, is there a right way to do this? What is the underlying process that is being modeled by these different mathematical statements? Now, perhaps one way we can look at this is that in fact, what we are trying to capture is several time series. Domain general skills, they develop by themselves, either depending or independently of domain specific skills. But if we take 3 time points, we can measure each of these things at each time point. So can math performance. So to a certain extent, I think what each of these 3 studies are capturing are aspects of these more complex model. Now, recently I submitted a paper looking at SES and the extent to which working memory differences is due to parenting skills and also SES differences. And the reviewer came back and savaged it and said that, you know, you really shouldn't be using cross-sectional design because it takes time for SES effects to impact on parenting skills, and that in itself also takes time to impact on working memory. But I don't know whether that's true. I know in some studies there has been studies to look at this, and the argument is that without accounting for previous skills, one is missing out on a large part of the paper or of the overall pattern. But then the thing is, if we look at performance here, right, and we put in this regression term, what is left behind, the variance that is left behind here is what is not predicted by domain-specific skills at time 1. Now, if domain-specific skills are relatively stable across time, it stands to reason that there's actually very little variance left to be explained. And typically what one finds is that when you look at cross-sectional findings, you get very high correlations. And then when you look at longitudinal findings, there's not much left to predict. Now, does it mean that domains general skills don't predict or are not related to domain specific skills? Or is it that because we have accounted for what happened last year, there simply is not that much left to be explained? So I'm still thinking over that one. And perhaps if we have some time left at the end, we can open this up and discuss whether there's a definite right way to run these analyses. Okay, so just a final point about implication. Perhaps a natural question to ask is, given this kind of studies, what can we draw from them? Should one say something about where one should focus intervention efforts? Now, the present findings seem to suggest that domain-specific constructs have stronger explanatory power, and coupled with findings that intervention efforts that are based on domain general constructs, for example, working memory, have shown very limited success. Should one then just focus intervention on domain-specific intervention? And perhaps at this point, we can open up the floor for discussion. I've done a couple of domain general intervention and mixed success. But looking at the field, I think there is a argument to be made for perhaps focusing much more on the domain-specific intervention rather than domain general one. So I think my time is up. So let's perhaps we can open up the floor to discuss questions about intervention, method of analysis, or any other questions that the audience might have.
I really appreciate that discussion, Kerry. And I think that last point about kind of the different ways of modeling the changes or the relations between domain general and domain specific skills with math is really interesting, because in my experience, and this might not be true of everyone, you can try all those different models and they'll all fit fine and they'll all tell you something. And typically it's that domain specific and domain general skills both do contribute to math, but there are the theoretical implications of one model versus another can be huge. Thinking about kind of growth or change or bidirectional processes, and the data alone can't necessarily tell us whether one is a better fit than another, which I think is a really interesting problem that I'm running into as it comes to kind of what conclusions do we draw from our data and what are the implications of our methodologies and approaches. Which is not a response so much as a yes and.
So thank you very much. So is there any other, are there any other problems? So if no, that's the end of today's symposium. Thank you very much and wish you all an early Merry Christmas. Okay, thank you. Bye-bye.
Thank you, everyone.
Thank you, bye-bye.
And Merry Christmas.
Merry Christmas, everyone.
Merry Christmas.
Merry Christmas and bye-bye.
Bye-bye.
See you all in 2021.